Hello students, I hope you are fine. Today we will learn a very small concept but very important concept, composition of functions, which has wide application in our real life, and it is also important for your class 12 board examination. So from school situation, how we are using composition of functions. This boy is Alpha and he has roll number 1 in the class. He is Beta, his roll number is 2. She is Gamma, her roll number is 3. She is Delta, her roll number is 4. So, Alpha, Beta, Gamma, Delta constitute the set of students. 1, 2, 3, 4 constitute set of roll numbers. A function can be defined from set of students to set of roll numbers. Now they are going for board examination. Roll number 1 has given board roll number 3001 and roll number 2 has been given the board number 3002 and 3 3003, 4 3004. So this constitutes CBSE roll number. So there is a relation between school roll number and CBSE roll number. So a function can be defined from set of class roll number to CBSE roll number, isn't it? Yes. Now, similarly we can define a function now from set of students to CBSE examination roll number because each student is also given a roll number. One is related to 3001, second is 3002, Gamma is 3003 and Delta is 3004. So this is the meaning of composition function. Now let us go to here. After the examination, the board examination for fair marking of the examination copies give a code number to each student. So that time it does not see the set of students, it does not see the class roll number. So each code number is associated with CBSE examination roll number. So 3001, suppose given a code number 16032, 3002 is given 33, 34 and 35. So a function can be defined from CBSE exam roll number to code roll number. Next, we can think of many functions now from set of roll number to code number, from set of students to code number, from roll number to CBSE number, students to exam roll number. So this is called composition function. So we have taken three sets, a set of roll number as A and CBSE roll number as B and code number as C. Now let A be the set of roll numbers as I told, B is the set of CBSE board roll numbers and CB set of CBSE code numbers. So a function is defined from A to B. A function is defined from A to B. F of A is equal to board roll numbers. So what will the order pairs? It will be 1, 3001, 2, 3002, 3, 3003 and 4, 3004. So a function is defined now, set of B to set of C. Let it be G. So G is defined from B to C by G of B is equal to code number. So the order pair in G will be 3001, 16032, 3002 with 16033, 3003 to 16004, 34 and for 3004 it is the order pairs. Now composition function. We will define a function from A to C which will be composition of F and G. It will be denoted by GOF. It is read as G of F. It will be written as G of F defined from A to C given by G of F x is equal to G within bracket Fx for all x belongs to first set A. So the order pair of G of F is equal to 1 will be associated with 32, 2 will be 33, 3 will be 34 and 4 will be 35. I hope you understood. Now I have written a question. Find G of F and F of G if function is defined from R to R and G also defined from R to R given two functions such as f of x is equal to cos x and g of x is equal to 3x square. Now second part of the question is show that g of f is not equal to f of g. So g of fx is equal to g of fx. That means in g of f we will replace x by fx. So gx is equal to 3x square. So in place of x I'll write cos x. So it will be g of cos x is equal to 3. Instead of x square we'll write cos x whole square. So the answer will be 3 cos square x. Next, f of gx. So f of gx means f of gx. So in f of g, x is replaced by gx in f. That means in place of x we'll put whole gx. So what is gx? Gx is equal to 3x square. So 3x square will be in place of x in cos function. So cos In place of x, 3x square. So are they equal? No, they are not equal. Another question. Functions f and g are defined, both are defined from real number to real number. Fx is given by x square plus 1 and gx given by 2x minus 3. Find f of g, find g of f, find f of f, find g of g. So I hope you can try. Pause the video, try to write yourself. If you are able, then it is great. Otherwise, you can take the help. So f of gx is equal to f of gx. So in place of x, we'll put whole gx. So it will be 2x minus 3 whole square plus 1. In place of x, we put 2x minus 3. Next is g of x. So in place of x, we'll put whole fx in gx. So it will be twice x square plus 1 minus 3. Of course, you will simplify to get the answer. F of f is equal to whole fx will be put in x of fx. So it will be x square plus 1 whole square plus 1 again. Next is g of g. So whole gx will be put in x of gx. So it will be g of 2x minus 3. So twice 2x minus 3 minus 3. So you simplify the answer for getting marks in examination. Let us learn some more facts about composition function. Let f is defined from a to b and g is defined from b to c are two functions. Then composition functions of f and g denoted by g of f written as g o f. It is defined as the function g of f from a to c given by g of fx is equal to g fx for x belongs to a. If f a to b and g b to c are both 1 1, then the composition function g of f a to c is also 1 1. If a to b and g function b to c are both onto, then g of f is also onto. If function a to b and g function b to c be given functions such that composite function is 1 1, then f is 1 1. If function a to b and g function b to c be given such that composite function of g of f is onto, then g is also onto. Next concept is invertible functions, or which functions are invertible. To learn it, let us recapitulate different types of functions we have already learnt till now. First is injective function. A function f x to y is defined by 1 1 if the image of distinct elements of x under f are distinct. If images are not distinct, then f is many 1 or not 1 1. Next is surjective function or onto. A function f x to y is said to be onto if every element of y is the image of some element of x under f. So we have learned that how to distinguish onto and into. If f x to y is onto, if and only if range of f is y, and if x to y is into if and only if range of f is a subset of y. So depending on this domain and range, we can categorize the function into four categories: 1 1 on 2, 1 1 into, many 1 on 2, and many 1 into. Now let us see when a function, which type function will be invertible. So these are the ray diagram of different functions. First is 1 1 1 2, second is 1 1 into, third is many 1 on 2, and fourth is many 1 into. And this is, you have already know it. Now suppose we will define its inverse. That means we will start from y to x, or y will be domain and x will be range. So let us see in which cases the function can be defined if we will define function from y to x. Can it be for 1? Yes. Can it be for 2? No, because y4 has no image in x when we will define from y to x. So this will not be a function. Next is third, many 1 onto function. So can it be a function? No, because y1 will have two images, x1 and x2, when we will define function from y to x. So that is also not a function. Fourth one, it will not be a function because again y2 is left, which has no image in x when we'll go in a inverse way or reverse way. So which function is invertible? So 1 1 onto function is invertible. We can write the function from y to x. A function f x to y is invertible if and only if f is a bijective function, means it is 1 1 as well as on 2. That is called bijective function. Now I hope you have enjoyed. Many more concepts will be continued. You can do all exercise question till that. All the best for your coming days. Be happy, be healthy, and try to get your target. So subscribe. Thank you for watching. Please share the video with others. Please don't forget to subscribe.